Solve the equation. 6 over 2x minus 2 plus a half equals 3 over x minus 1. So in this one, I actually have three different denominators. So I'm going to do a little work to get a common denominator before I just multiply both sides by it. So I'm going to factor what I can, and I'm going to draw some big fraction bars. Some parentheses. Okay, so now I'm trying to build a common denominator. This is the toy box thing, right? So this is like three different toy boxes. We need them to match so that all the children are happy. So this toy box has a 2 and an x minus 1. It looks at the other two and says, there's nothing in here that I don't have. There's nothing in here that I don't have. So this toy box is complete. We move to the next one. So this toy box has a 2 in it, and it looks around and it sees that some of the other toy boxes have x minus ones. And so it wants an x minus 1. So we put x minus 1 on the bottom, and we also have to put it in the top. And then the third fraction, to look like the other two, it needs a 2. It needs a 2. So we would put a 2 here on the bottom and on the top. And now that they all have the exact same denominator, I can multiply both sides by that common denominator, and that will have the effect of canceling all the denominators. Okay, so all my denominators cancel now, and I am left with 6 plus x minus 1 equals 6. So x minus 1 equals 0, so x equals 1. Before I just circle this and say it's the solution, the answer would be A, right? Because there's one solution, it's in this list. I should check to make sure that it's actually a solution, because this can happen with rational equations. So if I try to put x equals 1 into my original equation, I get 6 over 2 times 1 minus 2 plus a half equals 3 over 1 minus 1, which gives me 6 over 0 plus a half equals 3 over 0, right? And the question is, are these equations true? They can't be, because 6 over 0 and 3 over 0 are undefined quantities. Okay, so this is actually not a solution, okay, because it leads to an equation that doesn't make any sense. So in this case, there are exactly no solutions.